Welcome to the Drowsy Science Channel, and hello. We'll be gazing up into the night sky tonight, which is a huge and stunning region. A land full of wonder, light, and unsolvable riddles. The usual views are above us. We are all familiar with the planets, the moon, and the constellations. However, there's a lot more to it than meets the eye. The light from a few of the stars we can see has already dimmed. From millions of light years away, a small cloud may be a whole galaxy. Furthermore, a meteor's dazzling light could be nothing more than a grain of sand. The night sky is both commonplace and breathtaking, something that never ceases to astonish us, even though we see it every day. I encourage you to like, subscribe, or leave a brief comment if you appreciate my introspective musings. It also makes it easier for others to find their way here. One drowsy person at a time. Right now, though, you just need to relax, find a place to call home, and let the serenity of the night sky carry you. Let's get started. All of the stars visible to the unaided eye are part of our own galaxy. The stars strewn over the heavens can seem endless when you step outside on a clear night and allow your eyes to acclimate to the darkness. However, each and every one of those light spots that are visible without a telescope is a neighbor and a component of our own Milky Way galaxy. According to astronomers, the unaided human eye can see about 6,000 stars in the entire sky under ideal circumstances. When you contrast that with the actual population of the Milky Way, which consists of hundreds of billions of stars, you can see how small the sample is. The stars of the galaxies farther away, such as Andromeda, or the dim smudges of distant spirals, are just too far away to be seen separately. Rather, they dissolve into spectral lights. The smallest portion of the enormous community of suns that we inhabit is what your eyes can see. Even though some stars in the night sky have already died, their light is still moving in our direction. Observing the stars is like gazing into the past. Although light travels at a tremendous speed, even starlight takes years, centuries, or even millennia to reach its destination due to the vastness of space. It's possible that some of the sparkling objects you see on a still night were gone long before people started constructing cities. You are receiving a picture of what a bright star 100 light years away looked like a century ago. In such instances, the star itself might have vanished. He might have burst as a supernova, imploded, or swelled into a red giant. However, as if nothing had changed, its light continues to race outward, continuing to bridge the chasm of space and reach us. It implies that the night sky is a living repository of the past rather than a snapshot of the present. Every glimmer above us is simultaneously present and absent, alive and dead. The compass North Star hasn't always been Polaris. Polaris has long been a dependable travel companion for those in the Northern Hemisphere. It indicates true north in the sky and is situated nearly directly above the North Pole of Earth. But in a cycle known as precession, the Earth itself sways slowly on its axis. This slow movement moves the stars in relation to our poles over thousands of years. Our North Star hasn't always been Polaris, and it won't be for long. For instance, the star Thuban in the constellation Draco was known by such a name in the time of the ancient Egyptians. It will be replaced in 12,000 years by the bright Vega. Because of this long heavenly dance, humanity's compass evolves over time. Tonight, when we stare at Polaris, it seems endless, steady and luminous. Even so, it is but one marker in a lengthy and ever-changing cycle that is inscribed on the sky. Ancient explorers used patterns in the night sky to find their way across deserts and oceans. The sky served as the first map created by humans long before satellites and compasses. In order to navigate featureless waters, sailors traversing the wide Pacific Ocean learned the rise and fall of constellations by heart. In desert regions, nomadic peoples followed suit, orienting themselves based on the positions of the stars. Particularly useful for determining direction was Polaris, which was consistently visible above the northern horizon. Navigators used the Southern Cross in the southern hemisphere. These observations gave rise to entire knowledge systems. For instance, hundreds of star positions were memorized and passed down through the centuries by Polynesian wayfinders. These were more than useful maps. They could never be forgotten because they were cultural gems that were incorporated into songs and legends. The same compass points that formerly led armies, explorers, and caravans across continents and oceans before the invention of any mechanical instrument are visible when you look up at the night sky. We are viewing the Milky Way via its disk, which makes it appear as a fuzzy band. A hazy river of light spreads across the sky on a genuinely dark night, far from the lights of the city. The combined light of billions of far-off stars is what gives the Milky Way its brightness. We are inside the galaxy, staring along its flat, disc-like structure, which is why it forms a band. Imagine looking through the rim of a huge rotating wheel while standing inside of it. From Earth, that is what we see. A bright haze is created by the concentration of stars, gas, and dust in the disk. It was dubbed the backbone of the night, a root of spirits, or a celestial river by ancient societies all across the world. We now refer to it as our galaxy's plane, and each luminous speck in that ring represents a different sun, solar system, or potential world. Both home and horizon are found in the Milky Way. There are hundreds of billions of invisible suns in our galaxy. Only a small portion of our galaxy is made up of the stars you see above. There are between 200 and 400 billion stars in the Milky Way, according to astronomers. Without telescopes, most of them are too far away or too faint to be observed. A great number of them are red dwarfs, which are tiny and faint in comparison to our Sun. Others are obscured by dust and gas clouds. Only infrared observations could disclose their brightness. Innumerable wandering worlds, planets unattached to any star, may likewise exist, gliding through the night without anyone noticing. The realization that the Milky Way's actual population is much smaller than what you perceive when you gaze up at a night sky full of thousands of stars is a sobering experience. There are so many suns in our galaxy that no one could ever count them all in a lifetime. Shooting stars are only cosmic dust grains that blaze in the night sky. They are not stars at all. A shooting star's streak seems enchanted, abrupt, brilliant, and fleeting. However, these flashes are not stars, despite their name. They are often pieces that are no larger than a pebble and frequently less than a sand grain. They light brightly before dissolving when the air in front of them warms up and compresses as they descend into Earth's atmosphere at tens of thousands of miles per hour. The majority never make it to the ground. What we see is a farewell spark in the sky, their last fire. Some come from comets, and each year Perth traverses streams of dust left by the comets. Others are just stray pieces of junk in the solar system. Despite their small size, speed and energy, rather than size, are what give them their brilliance. The universe gives us a little reminder that space is never still in every streak. Thousands more stars emerge in the night sky from Earth's deepest regions. The majority of us live under artificially dimmed skies. The stars are obscured by cities, bright highways, and street lamps. However, the view completely shifts in the few locations that are not affected by this light, such as isolated islands, mountaintops, and remote deserts. The heavens become packed with thousands and thousands of stars instead of a few dozen dazzling spots. The Milky Way expands into a wide, glistening arc that is sufficiently bright to create shadows. You can spot luminous star clusters, dim smudges that are actually far-off galaxies, and occasionally even the delicate hue of a nebula in these skies. These locations are known as dark sky sanctuaries by astronomers. They are also becoming less common. To stand beneath one is to witness what all people witnessed before the invention of modern lighting. a star-filled universe that is both magnificent in its clarity and humble in its vastness. Light pollution prevents certain locations from ever seeing the Milky Way. The Milky Way is no longer a part of everyday life for a large number of people worldwide. In densely populated areas, it has been obscured by artificial light. The river of stars that was formerly essential to human culture is never seen by entire generations. It is not only the stars that are dimmed by light pollution. Only the brightest planets and a few isolated spots remain after they are totally submerged. Night-glowing cities emit light upward, dispersing it throughout the atmosphere and forming a persistent haze. Consequently, the Milky Way is essentially extinct in some locations. But beneath the curtain, the stars remain, waiting. For the sake of research and our feeling of awe, astronomers and environmentalists are striving to protect the black sky. Reconnecting with a view that belongs to all of humanity is the experience of seeing the Milky Way with your own eyes. Over the course of thousands of years, constellations gradually change shape. The patterns of constellations, which seem to be frozen in the sky and have been passed down through the generations, have an enduring quality. However, the stars that comprise Cassiopeia, Ursa Major, and Orion are actually not fixed positions. Every star in the galaxy is traveling at a different speed and on a different path around the galactic center. We cannot detect their movements in a single lifetime due to their great distance. However, over tens of thousands of years, the well-known contours start to distort and disappear. Eventually, Orion's belt will no longer be straight. At this point, the Big Dipper will no longer resemble a dipper. To see how the sky will seem in the far future, astronomers can make time projections. The constellations are also almost unidentifiable. The night sky is a slowly changing dance rather than a static image, demonstrating the true dynamic nature of our galaxy. Constellations that are invisible to northern eyes are visible in the southern hemisphere. Traveling south of the equator after dusk can feel like entering a different universe for someone who was raised in a northern climate. The Big Dipper and other well-known constellations entirely disappear as they descend below the horizon. New shapes appear in their place. Navigators have long employed the tiny, brilliant Southern Cross. The two nearby Melanic clouds, tiny galaxies circling our own, are visible to the unaided eye as spectral smudges. Whole star formations create constellations that northern stargazers are unfamiliar with, like the emu in the sky that native Australians are familiar with, or the Grand Centaurus marching across the sky. These constellations are as familiar and natural to people in the southern hemisphere as Orion is to those in the northern hemisphere. They serve as a collective reminder that the sky belongs to everyone. However, everything is altered by perspective. The universe overhead is constantly bigger than we realize, and half of Earth sees a perspective that the other half never does. Without a telescope, it is possible to see the Andromeda galaxy in the night sky. One galaxy is close enough to be seen with the naked eye, but most are far out of sight: Andromeda. It seems more like a cloud than a constellation when viewed under a dark sky as a faint, hazy haze. But the size of that blurry smudge is astounding. Like our own, Andromeda is a spiral galaxy with a diameter of around 200,000 light-years and possibly 1 trillion stars. It took more than 2 million years for its light to reach Earth. Long before telescopes were invented, ancient observers also noticed it and noted it as a dim patch among the stars. One of the most humbling things about astronomy is realizing that you can go outdoors, look up, and truly see another galaxy with your own eyes. There is more than one thing in that faint haze. It's a whole island universe with its own planets, suns, and mysteries. The journey of the Andromeda light started about 2 million years ago. You are gazing into the distant past when you catch a glimpse of the Andromeda galaxy's dim glimmer. Its light has traversed intergalactic space for over 2 million years. That implies that the light that is reaching your eyes tonight left Andromeda a long time before people were even born. Earth was inhabited by early ancestors who had not yet acquired the tools and language we take for granted when that light set out on its trip. In the time it has taken for that dim glow to shine through the emptiness, entire species have risen and fallen. Furthermore, even though we perceive Andromeda as it was, the galaxy has changed, grown, and is still producing new stars. Andromeda and the Milky Way will collide and become one large galaxy in another 4 billion years. For the time being, the light from its old stars transports history over unthinkable distances, acting as a living time capsule. There were stars in the night sky that are no longer there. It is simple to consider the stars to be everlasting, permanent lights above us. However, stars are created, grow, and pass away, often violently. Astronomers analyzing old star charts sometimes find descriptions of dazzling objects that no longer glow in the sky today because starlight takes time to reach Earth, and some of the stars described in ancient times have subsequently died. It's possible that these were enormous stars that ran out of fuel and burst into supernovae, leaving behind only hazy relics. Others might have fallen into black holes or neutron stars, which are invisible without specialized equipment. Even when the stars in the sky die off, new ones are created, rejuvenating the sky. What we see above us is a dynamic narrative, a record of both the present and the past, rather than a static tapestry. Even though a sparkling point's life is vastly longer than ours, it is nevertheless only transitory. From cold red to dazzling blue, a star's color indicates its temperature. Not every star has the same brightness. Some have a pale blue-white brilliance, while others glow a soft orange-red. There is more to this distinction than meets the eye. Their temperatures are shown. Red stars, which radiate at a few thousand degrees, are cooler and are sometimes referred to as red giants or red dwarfs, depending on their size. On the other hand, blue stars burn at temperatures of tens of thousands of degrees, with extremely hot surfaces and brief lives. Our own Sun, a medium-temperature star, is situated in the middle, with its constant yellow-white light. These hues are like fingerprints to astronomers. They are able to measure temperature, composition, and even motion by dividing starlight into its spectrum. Star colors appear faint to the human eye and are frequently obscured by the atmosphere. But you can identify them with practice. Every hue reveals something about the composition, energy, and position of a star in the vast cosmic life cycle. Because of Earth's atmosphere, stars appear to twinkle in the night sky. Like nature's own brilliance, a star's twinkling can be entrancing. However, what you're actually witnessing is atmospheric turbulence. Above us, a starlight moves through the layers of air. As temperatures and densities change, it slightly shifts and bends. Even though the star is shining constantly, the effect gives the impression that the light is flickering or jumping. In contrast, because they are closer and display a bigger disk of light, planets typically appear more stable and are less impacted by the moving air. This phenomenon is known to astronomers as atmospheric scintillation, and that's why earthly telescopes can never reach flawless clarity. In order to get around it, observatories are constructed atop mountains, where the air is more stable and thinner, or they are even sent into orbit to completely avoid the atmosphere. It is actually a memory of the thin, erratic layer of air beneath us that appears to be a mystical shimmer. Those same stars shine steadily clear in space. Our perception of stars differs greatly from that of astronauts on board the International Space Station or spacecraft outside of Earth's atmosphere. Starlight comes in perfect beams, steady and unflinching, without the continual interruption of air currents. There is a noticeable difference. Stars shine precisely, not like dots that twinkle. A fixed diamond against the darkness, each one. This clarity is one of the reasons why images of amazing detail that are liberated from Earth's atmosphere are produced by telescopes such as Hubble. They are able to depict the universe as it actually appears. The fainter hues of stars are also more clearly visible in space due to the constant brightness than they are from Earth. The view from orbit depicts the sky in its unadulterated state, stable, bright and clear, but twinkling can evoke feelings of romance or nostalgia. It serves as a reminder that while our atmosphere shields us, it also subtly hides the fundamental nature of the universe. Deep within, some stars get hot enough to fuse carbon and helium. Nuclear fusion, which is the act of forcing smaller atoms into larger ones, provides a star with its energy. A star converts hydrogen to helium during the majority of its existence. Massive stars, however, don't end there. They start combining helium into carbon, oxygen, and even heavier elements as their cores get hotter and denser. The foundation of life itself is constructed by this cycle. Every carbon atom in your body and every oxygen molecule you breathe was produced inside a once-burning, flaming star. These elements are released into space to seed new stars and planets when such stars eventually collapse and explode when they reach their limits. With each star generation producing the raw elements for the next, the universe functions as a sort of recycling system. We see furnaces that shape the future, whether we gaze up at a dazzling blue giant or a dying crimson supergigantic. The brightest star in the night sky is Sirius. Sirius, sometimes referred to as the dog star, is so bright that it rules the night. It is located in the Canis Major constellation and has a brightness that is almost double that of Canopus, the next brightest star. It has lived up to its reputation over generations and cultures, and its name is derived from the Greek word for glowing. Its proximity contributes to some of its brilliance. One of our closest star neighbors is Sirius, which is barely 9 light-years away. It is more than 20 times brighter than the Sun, but it is also naturally luminous. The rising was anticipated by the ancient Egyptians, who connected it to the Nile's inundation. It remains one of the most trustworthy indicators in the winter sky today. Even from cities, it's easy to notice. Sirius is also not alone himself, lone. Every 50 years, a faint white dwarf companion, the dense core of a long-dead star, circulates it. Almost every civilization has myths about Sirius. Sirius has served as more than just a source of light throughout history, from ancient Mesopotamia to the Pacific Islands. It has served as a guide, an omen, and a symbol. Its annual ascent was woven into the Egyptian calendar because they connected it to the Nile's life-giving rains. We got the term dog days of summer from the Greeks, who associated it with heat and insanity. It was a crucial star for lengthy journeys in Polynesian navigation techniques. It was mentioned in myths and seasonal indicators among North American indigenous peoples. Cultures all throughout the world have acknowledged its genius and assigned meaning to it, connecting it to cycles of migration, agriculture, and narrative. The fact that Sirius may represent so many different things to so many people is evidence of its potency. All it is a star, a sphere of flaming helium and hydrogen. Nonetheless, it is one of the most enduring emblems of the sky due to its position in human imagination. In the night sky, the Pleiades cluster gleams like a little swarm of fireflies. One of the most adored vistas above is the Pleiades, often known as the Seven Sisters. Even in places with moderate light pollution, this little group of stars in Taurus can be seen. Although there are hundreds of stars in the cluster, most people only see 6 or 7 when looking at it. The vista becomes a dazzling swarm when viewed through binoculars. Every star is a young blue sun that is blazing brightly. The Pleiades were acknowledged by ancient societies all over the world, and they were frequently incorporated into family or pursuit tales. The cluster's Japanese name, Subaru, is now permanently incorporated into the emblem of the automaker. Only roughly 400 light-years separate us from the Pleiades, who are still obscured by light-reflecting dust clouds. They serve as a reminder that not all night sky beauty is remote or subtle. There are wonders that are intimately close. Orion's sword contains a faint glimmer from the Orion Nebula. A brief row of stars known as the Sword can be found beneath Orion's well-known belt if you follow the constellation. On dark evenings, a fuzzy patch of light that is visible to the unaided eye is located in the center of it. One of the galaxy's closest and brightest star nurseries is the Orion Nebula. It resolves as swirls of luminous gas illuminated by budding stars when viewed through binoculars or a small telescope. According to astronomers, thousands of stars are developing there and using their energy to shape the clouds. Ancient astronomers saw it as merely an enigmatic haze. However, we now recognize it as the starting point of the star narrative. The distance to the Orion Nebula is only over 1,300 light-years. It is now one of the most researched areas of the sky because it is so close. Every gaze at it is an observation of creativity in action. Nearby stars excite the gases in some nebulae, which is why they sparkle. Nebulae, which are light-year-long clouds of gas and dust, are the vast canvases of the universe. Some are powered by strong radiation from neighboring stars, which causes them to shine brilliantly. These enormous suns radiate ultraviolet light, which strikes the atoms in the nebula and causes them to release their own vibrant light. These are known as emission nebulae, and depending on the components they contain, they can produce red, green, and blue hues in the sky. One well-known example is the Orion Nebula, which glows pink due to hydrogen. These clouds would merge into the emptiness, black and unseen without the stars that give them energy. Rather, they act as bright lights, indicating areas where stars are formed. What appears soft and delicate to us is actually a maelstrom of activity that has been molded by gravity and energy into some of the most exquisite astronomical spectacles. Others, like cosmic mirrors, glow only by reflecting starlight. Not every nebula produces light on its own. Some only mirror the brightness of surrounding stars. They light more subtly and gently and are known as reflection nebulae. Similar to how dispersed sunlight makes the Earth's sky appear blue, dust grains within them scatter starlight, frequently giving them a characteristic blue tint. The nebulosity that surrounds the Pleiades cluster, where weak dust clouds are illuminated by brilliant blue stars, is a well-known example. Similar to cosmic mirrors, these nebulae capture and reroute light throughout space. The red supergiant Betelgeuse is hundreds of times larger than our Sun. Because it has used up all of the hydrogen that originally powered it, astronomers are aware that it is reaching the end of its life. Now, heavier atoms are fused inside, accumulating toward an inevitable collapse. The brightness of Betelgeuse fluctuates greatly, occasionally becoming so dark that it causes conjecture all across the world. A great fading LED in 2019 had many people question if it was going to blow up. Even though its radiance returned to normal, the incident served as a reminder of how delicate it is. As a twilight star, Betelgeuse's destiny is predetermined. If it survives for another 100,000 years, or even a small portion of that time, it will ultimately perish spectacularly. One day, Betelgeuse might detonate as a supernova, which would be visible in the night sky during the day. Betelgeuse won't fade subtly when it eventually reaches the conclusion. It will detonate into a supernova, a blast so intense that it will eclipse all other stars in the sky. The light from its demise can be visible during the day for weeks or even months, shining brighter than the full moon. Ancient astronomers noted that such an occurrence had previously occurred when neighboring stars crashed. The distance to Betelgeuse is roughly 600 light-years. It is far enough away to not endanger Earth, yet close enough for us to see its splendor. While its outer layers spread across space, filling the universe with components like iron and oxygen, the explosion will leave behind a dense remnant, maybe a neutron star. People everywhere will glance up when it occurs, seeing the same bright light in the sky. A reminder that stars also have unique lives and deaths. Whole galaxies can be momentarily eclipsed by supernovas. One of the universe's most violent events is the death of a big star. The collapsing core of a supernova rebounds so violently that the entire star is ripped apart in a single instant. The explosion can unleash more energy than all the stars in a galaxy put together for a short time. Such occurrences could appear as unexpected bright stars when none previously existed from Earth. Some remain for months, while others disappear in a matter of weeks. The elements created in star hearts are dispersed across the surrounding universe by supernovae, which act as cosmic engines beyond their visual display. The foundations of planets and life would not exist without them. A supernova's legacy lasts a lifetime, yet its brightness is short-lived. The power and impermanence woven into the fabric of the universe are both shown when one imagines a whole galaxy eclipsed by the death of a single star. The relic of an explosion that ancient astronomers observed in the night sky is known as the Crab Nebula. Observers in China and other parts of the world documented the unexpected emergence of a bright new star in the year 154. Before disappearing from view, it glowed brilliantly for weeks, even throughout the day. We now understand that the event was a supernova, which is the demise of a big star. The Crab Nebula, the remnant, is still visible in the sky. The explosion's expanding shell of gas and dust is seen through telescopes as a tangled web of incandescent filaments. There is a pulsar at its core. Like a cosmic lighthouse, the original star's collapsed spinning core continues to emit radiation pulses. The Crab Nebula is a living link between historical documents and contemporary astronomy, acting as a time capsule. Both the memory of a star's demise and the ongoing life of its remnant are visible to us when we view it. The precision of pulsar rotation is comparable to that of atomic clocks. One of the most peculiar objects in the universe is a pulsar. Following a supernova, they are the collapsing cores of enormous stars, primarily made up of neutrons. Their density is unfathomable. The weight of a mountain would be equal to a teaspoon of pulsar matter. Like lighthouse beams, the radiation from several pulsars sweeps over the universe as they rotate at incredible speeds. They seem like regular light or radio wave pulses from Earth, and since they arrive so consistently, astronomers can use them as cosmic clocks. While the fastest known pulsars rotate hundreds of times per second, some spin dozens. Astronomers can use them to measure cosmic distances and test the laws of physics because of their stability, which is comparable to that of the best atomic clocks on Earth. We are reminded that time itself can be written in starlight by these small, collapsed fragments. The magnetic fields of magnetars are billions of times more powerful than those of Earth. Magnetars are unique among the many unusual relics of dead stars. They are neutron stars, just like pulsars, but they have magnetic fields so strong that they are incomprehensible. The field of a magnetar can alter atomic structures itself because it is trillions of times stronger than Earth's. Vibrant twisting and snapping of these fields can result in high-energy radiation bursts that reverberate throughout space. They appear to astronomers as abrupt flares, powerful but brief. Magnetars are tiny, measuring barely 20 km wide, but they have the mass of several suns. Even at far distances, they are deadly due to their strength. The magnetic field of Earth might be severely disrupted by a nearby magnetar. Luckily, there are none in the area. Rather, they continue to exist as remote wonders, as harsh testing grounds for the laws of physics. Magnetars demonstrate that the cosmos is not only incredibly large, but also capable of producing forces that are almost unthinkable. Only their effects can disclose the hidden black holes in the night sky. A black hole is not anything that is directly visible to us. It is undetectable against the background of space because of its extreme gravity, which prevents even light from escaping. However, the way they alter their environment can be used to identify their presence. As everything spirals into a black hole, it warms up and emits a dazzling X-ray light before disappearing. Their gravity may cause stars to circle invisible partners, revealing the mass of black holes. The lines of light are distorted as space itself bends inward around them. Black holes are undetectable to the unaided eye. However, astronomers have discovered other ones dispersed throughout the galaxy thanks to telescopes and close observation. Some hide at the core of galaxies, while others are the remains of enormous stars. They serve as the invisible pillars of cosmic drama, serving as a reminder that the universe's most potent forces frequently lurk in the shadows and in quiet. Some flame brightly while feeding on neighboring stars. A black hole can pull matter from its partner when it orbits near a companion star. An accretion disk, a spinning ring heated to millions of degrees, is created when gas from the star spirals inward. The earnest, invisible black hole is one of the brightest objects in the sky at those wavelengths due to the strong X-ray radiation produced by this activity. As the flow of matter changes, it appears to an observer as a flickering beacon that occasionally gets brighter and occasionally fades. Extreme black hole conditions cause material jets to shoot across space for thousands of light years at speeds close to the speed of light. Consumption of a star may sound disastrous, yet it is a necessary component of the cosmic cycle that redistributes matter and energy. These striking systems demonstrate that black holes are active participants in determining the dynamics of galaxies, rather than being empty spaces. There is an extremely huge black hole hidden in the center of our galaxy. An invisible giant known as Sagittarius Asterisk, an extremely enormous black hole with a mass millions of times larger than the Sun, is located at the very center of the Milky Way. The orbits of stars swirling about it at amazing speeds betray its presence, even if it cannot be viewed directly. In 2019, astronomers used a global network of radio telescopes to record its shadow for the first time. The painting depicted a luminous ring of light encircling a dark core from which light itself is unable to escape, with matter spiraling inward and burned to extremes. It is believed that superhuge black holes like this one are the root cause of most galaxies, influencing their evolution through energy and gravity. It is both humble and inspiring to know that such a force is rooted in our own galaxy. It is the Milky Way's quiet core, invisible but incredibly powerful. There are innumerable galaxies in the night sky that are out of our line of sight. Even if it may seem like there are many stars above, this is just the beginning. There are innumerable galaxies in the cosmos outside of the Milky Way. There are billions, even trillions of stars in each. Faint smudges of light resolve into ellipses, clusters, and spirals when viewed through telescopes. There are island universes all around the universe. After days of staring at what appeared to be a blank piece of sky, the Hubble Space Telescope discovered countless hidden galaxies in an area as small as a grain of sand held at arm's length. This finding demonstrated that galaxies are abundant throughout the universe. Only a few, such as Andromeda or the Magellanic Clouds, are visible to the unaided eye. However, with the correct equipment, the darkness in between stars becomes a sea of light. The night sky is more than just a starry sky. It is the periphery of a huge galaxy cosmos. Galaxies can be seen through telescopes as ellipses, spirals, and chaotic shapes. Galaxies differ from one another. Some have sweeping arms of stars that curve outward from a brilliant core to form elegant spirals. Others are large balls of old stars that glow dimly, ellipses that are smooth and featureless. Others are asymmetrical, their forms warped by collisions or star formation explosions. Every type has a history story to share. Spirals are teeming with gas and nascent stars. Ellipticals are calmer, older, and frequently the product of mergers. The misfits who are still getting their bearings are known as irregulars. The diversity of galaxies is astounding when viewed through telescopes. Some glow brilliantly, while others are barely perceptible smudges. Each one, however, is a cosmos unto itself, with planets, stars, and innumerable mysteries. Seeing them is a reminder of the universe's boundless creativity, which shapes both chaos and order into bright shapes that float through space's gloom. In slow motion, some galaxies collide and merge. Galaxies themselves are not as isolated as the vast distances between stars within a galaxy. Their courses frequently cross, and gravity binds them into groupings and clusters. The collision between galaxies is a slow-motion dance that lasts for hundreds of millions of years, rather than a cataclysmic explosion. Their gas and dust clouds collide, causing bursts of new star formation, although their stars largely pass each other. Their forms are stretched by gravity into arcs, tails, and spirals. The galaxies eventually combine to form a single, bigger system. Such a fate awaits our own Milky Way, which will eventually merge with the Andromeda galaxy. The two will merge into a single gigantic elliptical galaxy in the far future. We observe others in the distance, their cosmic ballets captured in time for the moment. Every collision serves as a reminder that everything in the cosmos, including galaxies, is dynamic. Two satellite galaxies that can be seen in the night sky in the south are called the Magellanic Clouds. Two dim patches of light that resemble clouds stay close to the Milky Way from the southern hemisphere. These are the dwarf galaxies that circle our galaxy, the big and small Magellanic Clouds. Through telescopes, they show themselves as thriving systems full of stars, clusters, and nebulae, but to the unaided eye, they look like faint smudges. Their gravitational waltz with the Milky Way has twisted their shape, making them uneven. Stellar nurseries such as the Tarantula Nebula, one of the known most active star-forming areas, are found within them. The Magellanic Clouds are permanently submerged beneath the horizon, making them undetectable to northern viewers. They have been part of Southerners' cultural practices for generations, making them comforting companions. The fact that the Milky Way is a member of a wider family of galaxies that circle, merge, and shape one another across cosmic time is served as a reminder by these galaxies. Clusters of stars resemble sparkling, gravitationally bonded families. Not every celebrity lives alone. Many are born together in gravitationally connected groups known as star clusters. The size of these clusters can vary from tiny assemblies of a few hundred stars to enormous clusters of thousands. The Pleiades and other open clusters are young and loose. In interstellar clouds, their stars are still near where they were born. On the other hand, globular clusters are crowded, spherical collections of old stars that are crammed into bright spheres. Star clusters are visible to the naked eye as glistening knots that are more brilliant than the surrounding stars. They burst into areas of light through telescopes. Every light source is a sun with a unique tale to tell. Astronomers use clusters as laboratories to learn about the galactic past and stellar evolution. A family of stars that have been tied together for billions of years by forces that have endured is visible to those who stand underneath a dark sky and catch a glimpse of it. Hundreds of thousands of suns can be found in globular clusters. One of astronomy's most breathtaking sights is a globular cluster. Hundreds of thousands and occasionally even millions of stars can be found in these spherical clusters, which are only a few dozen light-years across. Stars are so dense in their centers that they seem to blend together like a swarm of fireflies. There are more than 100 globular clusters in our Milky Way, and the majority of them orbit the outer regions of galaxies. They include some of the earliest stars in the universe and are quite old, frequently over 10 billion years old. Telescopes show them as brilliant globes of light, globular groupings of early universe fossils that appear as weak, fuzzy patches to the unaided eye. Survivors from the early stages of galaxy formation. Their persistence is just as beautiful as their brilliant appearance. Throughout the history of the cosmos, a few of these clusters are almost as old as the cosmos. Globular clusters are preserved time capsules of the first stars to develop. Many are over 12 billion years old, almost as old as the universe itself. Very few heavy elements are present in these old stars, which is indicative of a period before supernovas had added the components necessary for planets and life to the universe. Studying them is like peering into a world that was almost primordial when stars were first starting to ignite in the dark. These clusters' tenacity is demonstrated by the fact that they are still found orbiting galaxies today. They have remained intact despite innumerable collisions, mergers, and gravitational disruptions throughout the galaxy. You are seeing more than just stars when you look at one through a telescope. You are seeing artifacts from the beginning of time, beacons of light that have lasted nearly as long as the universe. They are some of the earliest surviving creation witnesses. Every year, as Earth passes comet tracks in the night sky, meteor showers return. Earth travels through cometary debris streams on a number of occasions each year. Meteor showers are produced when innumerable small particles reach our atmosphere and burn up as we pass through their trails. In contrast to sporadic shooting stars, meteor showers create several streaks in a single night, frequently emanating from a single spot in the sky. Among the most well-known are the Perseids, Geminids, and Leonids, each of which is associated with a parent comet or asteroid. Because Earth travels the same routes year after year, these showers are predictable and occur on the same dates. They fill the sky with ephemeral streaks of light, making them one of the most satisfying sights for stargazers. The flaming tracks of the meteorites, which are frequently no bigger than grains of sand, serve as a reminder that Earth is always traveling through a living solar system and coming into contact with the remains of past explorers. One of the most well-known is the Perseid meteor shower in August. The Perseid meteor shower, which produces some of the most dependable shooting star displays, illuminates the skies every August. The Perseids are active for a few weeks, reaching their peak in mid-August, and originate from the debris trail of Comet Swift-Tuttle. Observers may spot dozens of meteors per hour during this time, sometimes more during bursts under dark skies. The Perseids are renowned for their swift, bright streaks. Many of them leave behind luminous traces that last for a few seconds. They get their name because they seem to radiate from the constellation Perseus. People have been watching the Perseids for centuries, making them a staple of summer evenings and incorporating them into legend. They still combine beauty and reliability, making them a favorite among stargazers worldwide. Every meteor is a little piece of a comet that burns brilliantly as it descends, serving as an annual reminder of the interconnectedness of Earth and the larger universe. Luminous showers sweeping over the night sky are described in ancient records. History has not overlooked meteor showers. Starbursts of falling stars, often hundreds in a single night, are described in ancient Chinese, Korean, and European texts. These documents frequently had symbolic meaning and were read as portents or omens. One notable Leonid shower in the 1830s generated thousands of meteors per hour, filling the sky with blazing streaks and evoking amazement and dread equally. Witnesses believed the end of the world was imminent. These historical reports are more than mere curiosity to astronomers. They aid in monitoring cometary orbits and meteor stream evolution. Scientists can learn how debris trails spread and change over millennia by contrasting historical records with contemporary observations. What was formerly thought to be a mystery fire in the sky is now understood to be a foreseeable cosmic occurrence. The astonishment, however, endures. The same feeling of wonder is still evoked as meteors fill the sky today. Because they were born from an asteroid rather than a comet, the Geminids are unique. Comets, brittle, icy rovers that leave behind lengthy dust trails, are the primary source of meteor showers. However, the Geminid, which is one of the year's brightest showers, originates from an unfamiliar source, an asteroid. Their parent body is compact and stony and exhibits characteristics more akin to a burnt-out comet than an actual asteroid. Every December, Earth passes above the dusty debris that Faten sheds as it gets closer to the Sun. Those grains ignite beautifully as Geminid meteors when they crash into our atmosphere. The Geminids are renowned for their intensity and range of hues, including flashing white, yellow, and even green, in contrast to many other showers. In a single night, hundreds of meteors might sweep across the sky at their height. They are special because they originate from an object that is neither entirely an asteroid nor a comet. A reminder that not everything can be cleanly categorized, a cosmic in-between. At night, fireballs can burn so brightly that they create shadows. Before you can even make a wish, the majority of shooting stars are only weak streaks. Occasionally, however, one shows up more brilliant than the others. The brilliance from these meteors, known as fireballs, can equal or even exceed that of Venus, the brightest planet in the sky. A real fireball has the ability to briefly create shadows, lighting up the surrounding area like a quick, silent explosion in the sky. They are typically brought on by larger rock or metal fragments, sometimes as large as a fist or even larger, impacting the atmosphere at extremely high speeds. They frequently leave behind luminous trails that last for seconds as they burn. Some break apart and flare repeatedly, as if they were disintegrating in flight. For thousands of years, people have been surprised by fireballs, which have evoked both wonder and horror. Seeing one serves as a reminder of the energy contained in even the tiniest pieces that are floating through space. Bolides burst apart with a tremendous explosion. A bolide is an extreme form of a fireball. It explodes, not merely blazes across the sky. With enough force, these dazzling meteors burst in the atmosphere, creating a roar akin to rolling thunder and a light that can compete with the sun. As was the case with the 2013 Chelyabinsk meteor in Russia, they occasionally shatter windows or tremble structures. When larger meteoroids, maybe a meter across, hit Earth's atmosphere at hypersonic speeds, bolides happen. They violently break apart due to the air's extreme pressure, releasing their stored energy in a massive explosion of sound and light. Bolides are most likely the source of the descriptions of booming noises and fire-filled skies found in ancient chronicles. They serve as a reminder that Earth is continuously moving through a shooting gallery of debris, despite their rarity. Some arrive dramatically, reverberating throughout the night and shaking the ground, while the majority burn innocuously. Every night, small meteors regularly graze across Earth. Earth is silently passing through streams of space dust, even on nights when there are no meteor showers. Our environment is constantly bombarded by tiny particulates that are frequently no bigger than sand. In an instant, each one burns up, too weak for most people to see. According to astronomers, almost 100 tons of meteoritic debris enter our atmosphere each day. In other words, there are always thousands of shooting stars above us, but very few of them are bright enough for humans to notice. Most particles disappear without being noticed, but larger ones sometimes flare brightly. The remains of comets, asteroids, and solar system collisions make up these cosmic specks, which wander forever until Earth happens to cross their path. The sky is never still when you gaze up at the stars. Every day, tiny fragments of the cosmos arrive and burn in the darkness without making noise. Certain meteors leave behind luminous trails that resemble smoke and linger in the night sky. Some shooting stars leave behind bright streaks that remain in the atmosphere long after the meteor itself has burned away, but the majority disappear in an instant. We refer to these paths as trains. They are created when the gases in Earth's upper atmosphere are ionized by a swift meteor, leaving behind a blazing trail of charged particles. Trains can shimmer for minutes in some situations, reshaping themselves as high-altitude winds twist and curl them. They can occasionally resemble smoke wisps. However, their own ghostly light makes them glow dimly, unlike smoke. To learn more about meteors and the winds at the edge of space, astronomers have examined their tracks. They rank among the most enchanted meteor shower spectacles for skywatchers. It fades gradually, as if unwilling to depart, like a signature left across the sky by something moving from one planet into another. Our nearest and brightest nighttime buddy is the moon. The moon has been our most dependable companion for as long as people have looked up. It is just roughly 238,000 miles away, much closer than any star. Its moods and forms, however, seem endless. It shines with the sun's reflected glow rather than its own light, waxing and fading in a cycle that affects how we perceive time. There is nothing else that has such total control over the heavens. Early civilizations used the moon as a natural clock, as well as a guide for storytellers and an inspiration for poets. The tides that form life along the coastlines are the result of its gravitational pull on our waters. The moon is constantly there, rising and setting with a silent regularity, unlike the roving planets or passing comets. To go outside and observe it is to share a view that all people have witnessed throughout history. Its phases functioned as the first calendar used by humans. Humans followed the sky long before there were written writings or carved stones. The moons were the most evident cycle to observe. Early observers were able to establish a consistent rhythm to life by witnessing it change night after night. The moon's shorter phases were immediate and obvious, in contrast to the sun's year cycle. Long before humans constructed their own, they connected the heavens to the necessities of life, transforming the sky into a clock and calendar. During lunar eclipses, the moon turns like a copper ball. Occasionally, the moon moves into Earth's shadow, and a remarkable event occurs. It acquires a rich coppery glow rather than going entirely dark. This is an eclipse of the moon. Earth's atmosphere bends sunlight, blocking out the bluer wavelengths and directing the longer, redder light into the shadow, which is why the moon does not disappear. Earth would appear as a dark disk with a ring of flaming sunsets surrounding it from the moon's surface. The lunar surface was illuminated by that red light, which we saw as the eerie blood moon. A shadow is cast on the land when the moon is exactly between the Earth and the sun. This shadow, however, is not motionless. It moves faster than sound, sweeping from west to east across the surface. Astronauts view it as a black, moving circle that crosses continents and oceans from above. The approach is obvious on the ground. The scene becomes quiet, the temperature decreases, and the light fades. The day turns to dusk in a matter of minutes. The whole eclipse, a brief moment when the sun disappears below the moon, is only visible to those who are within the limited path of totality. Darkness swept at the ancient inhabitants, and they must have been afraid. To see the unique geometry of three celestial bodies aligned, however, many people now travel thousands of miles to stand in that shadow. It serves as a reminder of just how delicate and exact the cosmic dance is. Stars appear in the midday sky during totality. The familiar is given a dreamy quality by totality. The moon completely blocks out the sun's blazing light for a few minutes, and a gloomy dusk descends in the middle of the day. Stars emerge in that weird light. Bright stars like Sirius or Regulus generally follow Venus, which is always the first to shine. It's also possible to see Mercury, which is difficult on a typical afternoon. The world becomes quiet. Roosts are occupied by birds. At night, insects start their symphony. Moreover, the air feels colder. The sun's corona, a delicate crown of light, extends outward above us and is typically obscured by the day's overwhelming brightness. It is shocking to witness stars burning in the middle of the day. It serves as a reminder that, whether we can see them or not, they are constantly there, patiently shining. Birth feels like a limbo between two worlds, day and night, entwined for those brief moments of totality. Eclipse predictions made by ancient astronomers were surprisingly accurate. Ancient astronomers diligently observed the skies even before telescopes were invented. They observed that eclipses were a part of recurring cycles rather than occurring at random. The Saros cycle, a roughly 18-year regularity that the Babylonians discovered, gave them the ability to predict eclipses with amazing accuracy. For thousands of years, Chinese imperial astronomers meticulously documented eclipses as omens connected to emperors' fates. The Maya constructed calendars that mastered the movements of the sun and moon by lining up their massive temples with them. These civilizations learned to predict astronomical phenomena that once frightened entire societies, even in the absence of contemporary knowledge. It must have been powerful to stand under a darkened sun and know that it would return, evidence that there was order in the heavens. Their meticulous documentation served as the basis for our own comprehension, transforming enigma into foresight and awe of the universe's patterns into respect. In the night sky, Venus shines so brightly that it can create shadows. Venus is not your typical light source. It is frequently the last to fade in the morning or the first to emerge in the evening. In the sky, a steady lantern. It is so bright that it can create small shadows on the ground under the darkest skies, something that only the full moon can do. Its dense, reflecting clouds effectively reflect sunlight back into space, giving it its brightness. Venus appeared to be double to the ancient people. The evening star glows after sunset, and the morning star rises before dawn. They didn't recognize it as the same celestial body until much later. Its phases, like those of the moon, were visible through Galileo's telescope, proving that it circled the sun. We now know that beneath its beauty lies a harsh exterior where pressure and heat destroy any visitors. But from Earth, Venus shines calmly, a bright light that casts shadows to indicate its existence. Jupiter shines brighter than most stars and does so steadily. Large and powerful, Jupiter is the planet's ruler. It is brighter than nearly every star and appears as a steady point to the unaided eye. Jupiter's light is continuous and recognizable against the constellations, unlike stars that sparkle through Earth's atmosphere. Ancient cultures loved Jupiter and associated its brilliance with thunder, might, and rulership gods. Its steady illumination conceals a turbulent world. A storm bigger than Earth, raging for generations, swirling in bands of color with a massive red point. Its unmistakable presence draws and holds the eye as it climbs into the darkness. Following Jupiter across the sky is like watching a giant in slow motion, one that is orbiting far away from Earth but is remarkably clear. Every time it shines overhead, it serves as a reminder of the solar system's vastness, where even the smallest glow conceals unfathomable enormity. When viewed with binoculars, its moons appear next to it as small gems. All you need is a steady hand and a pair of binoculars to witness one of the most basic astronomical miracles. If you look at Jupiter, you might notice 4 tiny lights next to it. Europa, Ganymede, Callisto, and Io are its largest moons. They disproved the notion that all celestial bodies rotated around Earth when Galileo discovered them in 1610. Night after night, they seemed to the sight like fine dots arranged in changing patterns. But everyone is a world. Mercury is smaller than Ganymede. Under its frozen surface, Europa conceals an ocean that might support extraterrestrial life. Volcanic eruptions occur often on Io, craters that predate recorded history scar Callisto. Observing them float about their enormous planet is like witnessing cosmic motion, evidence that the orbits of other worlds are far from our own. Their silent dance feels as revolutionary now as it was 400 years ago. Even the little telescope can see the rings of Saturn. In the night sky, Saturn is a serenely beautiful planet that is stable and brilliant. It appears beautiful to the unaided eye. However, the view changes when viewed through a small telescope. All of a sudden, a fragile, impossibly fragile universe surrounded by rings emerges. It is unlike any other sight. Despite being hundreds of thousands of kilometers in length, the rings are so thin that they nearly vanish from vision. They are composed of frozen pieces that orbit one another in glistening bands. Some are as little as dust, while others are as large as mountains. Galileo was the first to see them, but his unrefined telescope was unable to identify their nature. They are still a popular target for amateur astronomers centuries later, These rings don't last forever. Particles are falling into Saturn's atmosphere as they slowly disintegrate. They might disappear in 100 million years, but for the time being, they continue to be among the most beautiful sights the sky has to offer. Mars occasionally has a reddish light that is brighter than Jupiter's. Typically, Mars appears like a tiny red ember among the stars, hanging modestly in the sky. However, the red planet gets closer to us every 26 months when Earth and Mars align in opposition. It glows ruddily and strongly during certain times, outshining everything but Venus and occasionally even Jupiter. Ancient people named it after combat gods because they believed that its flaming light represented blood and war. Ice caps, shifting dust storms, and valleys sculpted by ancient rivers are all visible via telescopes. Mars becomes dazzling during big oppositions, brilliant enough to draw the attention of even the most casual stargazers. After that, it withdraws and disappears into the distance. It is cyclical in its brightness. Two planets in the same cosmic neighborhood beat together. Every close-up rekindles interest. An opportunity to gaze across the emptiness at a curiously familiar yet alien world that is only waiting for us to come back. Mercury hides close to the sun's brightness, making it difficult to find. Mercury is a secretive planet. It rarely veers high enough to be plainly seen, always snuggling close to the sun. Although it is visible a few times a year, most people have never seen it. Faintly glowing near the horizon, it disappears back into sunlight as it rises soon before dawn or sets shortly after sunset. It seemed to ancient observers as a quicksilver scuttling through the sky at an unusually high speed. Some cultures believed the morning and evening appearances to be two distinct planets because they were so difficult to follow. Mercury's orbit around the Sun became evident when Galileo's telescope showed its phases, which resembled those of Venus and the Moon. It faces a difficulty today, rewarding patient eyes in the most elongated moments. Mercury seems like a lost gem to those who discover it, a vanishing spark at the verge of daylight. Under perfect skies, Uranus and Neptune are hardly visible. The solar system reaches farther into regions where dim worlds revolve in stillness than the ancients could have imagined. Few people ever notice Uranus, a pale greenish dot that is just bright enough to be seen with the unaided eye from the darkest places. Without optical assistance, Neptune is even fainter and undetectable. Their findings are part of contemporary astronomy. William Herschel discovered Uranus in 1781. Whereas Neptune was originally identified in 1846 using mathematical predictions of its location. Today, to get a glimpse of them is to gaze at the absolute limits of what is visible from Earth. Through telescopes, Neptune displays stormy streaks of deep blue, while Uranus seems calm and featureless. They serve as a reminder that not all worlds are readily revealed. They are silent sentinels on the periphery of our planetary family, concealed in the shadows, dim and slowly moving, waiting for inquisitive eyes to come looking for them. Occasionally, comets with luminous tails crisscross the night sky. Occasionally, a visitor from the far reaches of the solar system shows up. A dust and ice comet travels inward toward the sun. It emits gas and dust as it warms up, creating a luminous coma and tails that can extend for millions of kilometers. These tails, which are shaped by solar wind and radiation, always point away from the sun. Some comets brighten up and take over the sky for weeks at a time. Millions were enthralled by Hale-Bopp in 1997 and Neowise in 2020, which attracted attention. Others are barely perceptible murmurs that can only be seen with telescopes. Comets have long evoked wonder since they can emerge out of nowhere and disappear just as quickly. They are pieces from the solar system's core as opposed to the stable planets and stars. Secrets of creation are stored in icy archives. One sweep across the sky is simultaneously timeless and fleeting, a messenger from the outside darkness. Some don't come back for thousands of years. Some comets circle the Sun in a few years, while others take millennia. Comets travel in extended orbits. Long-lived individuals may only be seen once in recorded history before disappearing into oblivion until they are rediscovered by distant generations. Beyond Pluto, their routes lead them into the Oort cloud, a huge invisible storehouse of ice objects at the frontier of the solar system. Gravity starts a journey that is measured in civilizations rather than lifetimes. Languages may have evolved, civilizations may have come and gone, and the Earth itself may have altered by the time it returns. Consider a sky watcher from ancient times who captured a comet thousands of years ago without realizing that the same body would ignite again in our own time. We are connected throughout history by these long-period comets, the story of innumerable human eyes focused skyward, stitched together by their infrequent returns. About once every 76 years, Halley's Comet makes a visit. One comet is legendary among comets. On average, Halley's Comet returns every 76 years and is bright, dependable, and well documented. Human history is intertwined with its appearances. It was noted by Chinese astronomers in antiquity. In 1066, it was portrayed in the Bayeux Tapestry as a sign of impending conquest. Born in 1835, Mark Twain passed away in 1910 while returning, as he famously predicted. It travels far into the inner solar system, where sunlight blazes on its frozen surface, causing it to glow brilliantly. It serves as a heavenly bridge connecting grandparents and grandchildren as generations pass between its visits. A reminder that cosmic cycles are much longer than human lifetimes. It won't fly over our skies again until 2061. It will also serve as a reminder once more of how time is endless and extends well beyond personal lives. Comets were considered a sign of impending doom for ages. Comets frightened people until science discovered their true nature. They came quickly, flashing over the heavens without warning, unlike the familiar planets and steady stars. Their erratic presence signaled upheaval, battles, plagues, and rulers' deaths to ancient peoples. Each was interpreted by the Chinese as a divine signal, and they kept careful records of them. They were feared hairy stars connected to blood and fire throughout Europe. Comets were known to portend disasters even during the Renaissance. Astronomers like Edmund Halley didn't start to see them as natural phenomena until the 17th century. Icy nomads on well-traveled routes. The weight of history is still present, but comets now evoke wonder rather than fear. One can sense the bare wonder that these unexpected guests once evoked by picturing a medieval peasant staring at a fiery comet, an omen from the abyss beyond, not beauty. A few comets have broken apart in direct line of sight of Earth. Not all comets make it all the way to the Sun. As heat causes their frozen bodies to shatter, some become unstable and disintegrate in front of us. Comet Shoemaker-Levy 9 broke apart in 1994 and struck Jupiter in a stunning collision. The scars from each collision are bigger than the Earth itself. More recently, Comet EAM, which was once expected to shine in 2013, broke apart as it approached the Sun, leaving behind only a little remnant. Observing a comet disintegrate serves as a reminder that these objects are delicate, tenuously held together, and remains of the early solar system. The very star that reveals them can cause them to abruptly flare in brightness before permanently disappearing. Although their devastation is spectacular, it also provides scientists with insight into their makeup, revealing mysteries from the early stages of planetary creation. Comets serve as a reminder of how fragile the foundations of worlds may be during their violent demise. Auroras cast glistening curtains of light over the night sky. Nights can occasionally be illuminated by ethereal light in the skies of the far north and south. As though painted by invisible hands, curtains of green, purple, and scarlet ripple across the heavens, changing and growing thicker. The northern and southern lights are auroras. They are created when solar particles that are charged travel toward Earth and strike our atmosphere. igniting atoms and causing them to glow. Every hue originates from a distinct gas. Whereas nitrogen glows blue and purple, oxygen tints the sky red and green. Auroras appear to be alive to those who see them, throbbing and moving with a beat that is otherworldly. For thousands of years, they have sparked mythology about wars fought in the sky, spirits dancing, or ancestors speaking. The beauty endures despite scientific comprehension. Under an aurora, which is created when solar wind strikes Earth's atmosphere, you can feel the planet's link to the sun right above you, inscribed in light across the night sky. Auroras start in the sun's furnace, far from Earth. Streams of charged particles are launched into space by solar flares and coronal mass ejections. Some of these make it to Earth, where they are directed toward the poles by our magnetic field. There, they collide with nitrogen and oxygen atoms in the upper atmosphere. Swirling displays dance over the Arctic sky as a result of those atoms absorbing the energy and then releasing it as light. On the ground, the process is amazing, but it is imperceptible from space. More intense solar storms intensify the lights and drive them farther from the poles, perhaps as far south as the southern United States or the Mediterranean. Because of the power and direction of the solar winds, every aurora is different. To see one is to observe how Earth's barrier turns unseen solar rage into beauty. Luminous serenity replaced violence. Auroras can show up virtually every night in the far north. For people who reside in high latitudes, auroras are frequent companions rather than sporadic wonders. The auroral oval arcs across the sky across Alaska, northern Canada, Scandinavia, and Siberia. And during long winter evenings, the lights may occur many times a week, sometimes nearly every night. They grow up used to their brightness, and on chilly evenings, locals go outside to watch the horizon throbbing with green or the drapes rippling overhead. In an attempt to glimpse them, tourists travel long distances and spend hours waiting in freezing darkness. The regularity of the aurora in some areas is a result of geography. More often than not, solar particles are directed into those skies by Earth's magnetic field. However, the awe of auroras never fades, even for those who witness them often. They are surprising yet predictable at the same time. Never the same, but familiar. Every night, sky is painted differently by the solar wind's unseen fingers. Beyond Earth, auroras can be seen shimmering over other worlds. These curtains of light are not unique to Earth. Auroras can also be found on other planets with magnetic fields. Jupiters are massive planets that are propelled into space by both the solar wind and their volcanic moon, Io. These auroras, which flare in ultraviolet light that is undetectable to the human eye, can be larger than the Earth itself. Even Uranus and Neptune exhibit auroras shaped by their tilted magnetic fields. And Saturn has its own, tracing arcs across its poles. On Mars, which has no magnetic field left, patchy auroras can be seen in certain areas. Planets' interactions with their stars and their own magnetic environments can be discovered by examining these lights around the solar system. Additionally, it serves as a reminder that auroras are not exclusive to Earth. Anywhere charged particle winds and magnetic fields collide, cosmic phenomena are created. Our perception of beauty is a universal energy signature. In the past, planting and harvesting were directed by the zodiac stars. Humans looked to the stars for direction even before calendars were invented. The 12 constellations that make up the zodiac, which trace the sun's journey across the sky, evolved into a celestial calendar. Farmers realized that the seasons were changing as specific stars rose at sunrise or set at sunset. While the return of Scorpio signified harvest, the arrival of Virgo or Taurus may indicate planting. By linking human survival to the movements of the skies, this useful knowledge contributed to the flourishing of civilizations. The zodiac evolved beyond a calendar over time. With constellations connected to fate and personalities, it developed into astrology. However, its origins were pragmatic, stemming from the necessity to gauge time and predict Earth's cycles. The zodiac is still familiar today, although the steady wobble of the Earth's axis has caused some tiny shifts in its stars. Its constellations serve as a reminder of the close connection between cosmic rhythms and human life. The Sun's annual journey across the constellations is indicated by the ecliptic. The Sun does not move aimlessly around the sky if you observe it from the same location each day. Rather, over the course of a year, it travels in a constant circle across the sky. We refer to this path as the ecliptic. The Sun seems to move from constellation to constellation along it, directing the seasons as they change. With their orbits in line with Earth's, the Moon and planets also remain around this line. The ecliptic was more than just a pattern to ancient sky watchers. The most significant celestial actors appeared on this stage, which served as the spine of the heavens. Astrologers still set their signs on it, and astronomers use it to map the positions of the planets. The ecliptic is a line carved into the sky by the rhythm of Earth's orbit around the star that provides us with our sustenance, and following it is like recreating humanity's first calendar. Over millennia, precession gradually moves the locations of stars. The stars are not absolutely still, yet they seem timeless, fixed in their constellations. The Earth's axis wobbles like a spinning top over thousands of years. The stars' positions in our sky are progressively altered by this sluggish movement, which is known as precession. As the North Star, Polaris now guides travelers and is located nearly exactly at the North Celestial Pole. However, some 5,000 years ago in ancient Egypt, Thubin, a different star, had that position of respect. Where Polaris is now, Vega will shine in another 12,000 years. Too slowly, the outlines of the constellations change as the background moves. These alterations are invisible to us. The ancient lights that have glowed above us for ages are joined by tiny metal emissaries. Everything save the Moon is frequently eclipsed by the International Space Station. One of the brightest objects in the night sky is the International Space Station, a laboratory that orbits 400 kilometers above Earth. It shines so brightly when sunlight strikes its enormous solar panels that it can match Venus and even outshine all other stars. It glides over the horizon in a matter of minutes, appearing to the unaided eye as a fast-moving star. It is an exciting sight for those who know when and where to look, and it serves as a reminder that humans are orbiting the Earth at speeds of over 27,000 kilometers per hour. There, astronauts live and work while performing experiments and observing Earth 16 times a day. The station itself, which was constructed by nations collaborating, is a representation of cooperation. Every time it passes overhead, it serves as a vivid reminder of our precarious existence in space and links the expanse of the sky with the human tail. For a short time, satellite flares can be as brilliant as Venus. Certain satellites are capable of more than just gliding. They flash. They shine brightly, outshining almost everything in the sky when sunlight strikes their surfaces at the ideal angle. This was the hallmark of the original Iridium satellites, which had flat antenna panels and produced brilliant bursts that could be seen from cities. The brightness of these flares could equal that of Venus, shocking onlookers. They disappear into the background after just a few seconds. They were both an annoyance and a marvel to astronomers, a remarkable illustration of orbital physics in action, as well as light pollution in one sense. Stargazers continue to be surprised by fresh reflections, even as satellite designs evolve and the iridium flares become less common. The interaction of sunlight, geometry, and technology is demonstrated when one sees a sudden flash from an artificial star, a brief spark connecting Earth to the apparatus in orbit. Occasionally, rockets leave luminous traces across the upper atmosphere. Rockets leave behind luminous trails that can extend for hundreds of kilometers as their flaming engines pierce the atmosphere during launch. Even when the Earth below is dark, These plumes at high altitudes enlarge and capture sunlight. The end effect is a breathtaking sight. As ice crystals scatter light, bright clouds twist and stretch, glimmering in rainbow hues. The sight can appear shocking to unprepared viewers, almost like a paranormal event. The higher reaches of the atmosphere, where sunlight and thin air mix to produce beauty, are actually the meeting point of human technology. For those who happen to glance upward, these displays, which are frequently visible over entire regions, transform ordinary evenings into spectacular events. They serve as a reminder that even the efforts of rockets, machines of force and fire, can leave a lasting impression on the sky. With more man-made lights in orbit, the night sky is now busier. The sky was solely the property of nature for the majority of history. The only moving lights were meteors, comets, planets, and stars. Humans, however, have added thousands of their own in a few decades. Today, space stations, satellites, and debris orbit the Earth, many of which reflect sunlight as they do so. These look like moving stars to the unaided eye, blazing through long exposure photos and crossing paths with constellations. The expanding swarm presents difficulties for scientists, disrupting observations and leaving traces on pictures of the cosmos. The location, however, can be oddly reassuring to casual sky observers as evidence that Earth has extended into space and left its own silent mark. The heavens are becoming a common area for both man-made and natural wonders. Every artificial light serves as a reminder of the aspirations of our species and the speed at which we have encroached ourselves into even the most serene areas. Magnificent views of the deep sea were made visible by the Hubble Space Telescope. The Hubble Space Telescope, which was launched in 1990, has given us unprecedented views of the cosmos. Its vistas of galaxies, nebulae, and star clusters have become legendary, filling books and screens with color and detail. It orbits well above the haze of Earth's atmosphere, capturing photos with clarity no ground-based telescope could match. Hubble has allowed us to imagine the sombrero galaxy, the pillars of creation, and innumerable brilliant clouds of star creation. Beyond aesthetics, it has contributed to important research by determining the age of the cosmos, monitoring space expansion, and revealing the mysteries of far-off worlds. It has been circling the planet for almost 30 years, providing a glimpse into the depths of space and time. Every one of its pictures serves as a reminder that the cosmos is a place of immense beauty that is patiently awaiting discovery, rather than being an abstract idea. There are several galaxies hidden in every area of darkness. You would anticipate nothing but darkness if you locate an empty area of the night sky and look directly into it. However, astronomers discover something astounding when they aim large telescopes at these areas. There are billions of stars in each of the thousands of galaxies that appear to be empty space. An entire island universe that is unfathomably distant is represented by each small speck of light that is captured. It's a humble realization. Even the most desolate area of the sky is not vacant. Its light travels for billions of years before it reaches us, forming alliances with galaxies piled throughout time. This implies that when we gaze at darkness, we are looking into plenty rather than emptiness. More worlds than we can imagine exist in the quiet places of the night, concealing richness beneath what seems to be nothingness. It turns out that emptiness is a myth. Thousands smaller than a grain of sand were discovered in the space by the Hubble Deep Field. Astronomers pointed Hubble at a tiny, seemingly vacant area of sky in 1995. The telescope collected dim light for 10 days while gazing into such darkness. The outcome was remarkable. That small view revealed about 3,000 galaxies. Tens of thousands were later found in deep fields. Hold a grain of sand at arm's length to grasp the scale. Its coverage area is comparable to that of the Hubble Deep Field. There must be hundreds of billions of galaxies in the entire universe if there are so many in such a little portion of the sky. There are billions of stars in every galaxy, and each one has the capacity to support worlds and even life. Astronomy was revolutionized by that one experiment, which demonstrated that the universe is more dense and rich than anyone could have ever imagined. It demonstrated how unthinkable abundance can be concealed in the most commonplace patch of black sky. Time itself moves in varied ways throughout the universe. Time is not universal, as demonstrated by Einstein's theories. It expands and bends in response to motion and gravity. Near a large star, a clock ticks more slowly than one far away. Time moves differently for a traveler near the speed of light than it does for a stationary person. This indicates that there are innumerable rhythms interwoven across the world rather than a single, shared rhythm. For example, in severe situations close to black holes, time appears to stop completely to an outside observer. There is a slight difference between astronauts in orbit and those of us on Earth. Depending on altitude, their clocks are running a little bit quicker or slower. There is no set time. It has elasticity. The stars above serve as a reminder that even something as basic as time itself is a part of the weird fabric of the cosmos, which is formed by the velocity and gravity of the heavens. All of the night sky's stars are glimpses into the past. You are not seeing the stars as they are right now when you look up at them. Light travels slowly. Furthermore, it is more than 4 years away from the sun to even the nearest star. For many, the distance is hundreds, thousands, or even tens of thousands of years. This indicates that their light carried a hint of the past with it as it started its trip long before you saw it. Even though their final light is still traveling to Earth, some of the stars you admire may already be gone, their fuel used up, and their brilliance destroyed. Looking up is a way to observe the skies as they were in the past, rather than as they are now. Cosmic archives are found in the night sky. Every star is a light-written page of history that has traveled through inconceivably long distances to reach us. Some are so far away that their light existed before people. Long before people ever set foot on Earth millions of years ago, the light from some stars and galaxies was moving so far away. When you view them, you are looking back into times before mammals evolved, or perhaps into times when dinosaurs controlled our globe. Long before people existed, long before there were ever forests or flowering plants, the photons that hit your eyes tonight began their trip. A portion of that light started its journey in an unthinkably young universe when galaxies were just starting to form. Looking at such far-off objects is like entering a timeline written in distance and stars, completely outside of human history. The stars transform from nighttime decorations into messengers of the deep past, narrating tales that predate humankind and go well beyond the duration of life on Earth. The afterglow of creation is known as the cosmic microwave background. Faint radiation, which is invisible to the human eye but detected by radio equipment, permeates the sky in all directions. This is the Big Bang's afterglow, or cosmic microwave background. The universe was hot, dense, and full of light that was unable to escape the thick plasma over 14 billion years ago. That light eventually spilled out and filled the entire universe as the universe cooled and expanded. Today, all that is left is a faint echo that has been chilled to a few degrees over absolute zero but is still there everywhere. Since its unintentional discovery in the 1960s, it has grown to be one of the most significant hints regarding our ancestry. Small variations in this afterglow reveal the potential formation sites of galaxies. Studying it is like seeing into the early days of the universe, when the first light escaped into darkness and the first memory of creation was inscribed on the sky. It is pervasive across space, yet invisible to the naked eye. There is no single region in the skies where the cosmic microwave background is concentrated. It permeates the entire cosmos. The signal is there, dim, constant, and ancient, no matter where you aim an antenna tuned to the correct frequencies. In actuality, this background radiation was responsible for a tiny portion of the static that was previously observed on vintage television sets. Every home is receiving whispers about the creation of the universe. Its presence cannot be denied, despite its invisibility. It explains that before the universe became the enormous, diverse place we live in today, it was unthinkably hot and homogeneous. It is humbling to realize that this same signature is present in every region of space. It implies that you are surrounded by the same relic light, regardless of where you are on Earth or in the universe. The silent remembrance of a creation that continues to haunt us. At cosmic dawn, the first galaxies formed in the heavens. The first galaxies formed billions of years ago, when the universe was young. The first stars were ignited by the collapse of hydrogen and helium clouds due to gravity. Massive, dazzling, and fleeting, these stars lived quickly before exploding brilliantly. Heavy elements, the building blocks of planets and life, were introduced into the universe by their deaths. Compared to the massive spirals and ellipticals of today, these galaxies were tiny and disorganized. However, they were the first to weave light into the gloom. This time frame, when the cosmos first started to glow with stars, is known to astronomers as the cosmic dawn. It is now necessary to look across vast distances and time spans in order to glimpse their dim glows. It was more than 13 billion years in the past. They serve as a reminder that everything that exists today, including stars, worlds, and living things, had their roots in that dawn. Peering back toward that dawn is the James Webb Telescope. The James Webb Space Telescope was intended to view farther back in time than any previous telescope when it was launched in 2021. It can detect the faint glow of galaxies that emerged just a few 100 million years after the Big Bang, thanks to its enormous gold-coated mirror and infrared-sensitive equipment. The Webb has already challenged our view of how the universe grew by revealing galaxies that are brighter and more massive than astronomers anticipated at such an early point in cosmic history. Its pictures include planets orbiting far-off suns, young stars encased in dust clouds, and light that has been stretched into red by the expansion of the cosmos. We are getting closer to the cosmic beginning when the first galaxies blazed, as a result of Webb peaks into previously unimaginable eras. Every new finding serves as a reminder that there are still mysteries in the universe that are just waiting to be discovered in the dim light that has been moving through the cosmos for billions of years. Some stars travel at dizzying speeds around the center of the galaxy. Everything in the Milky Way rotates around the incredibly huge black hole at its center, which acts as a gravitational anchor. The majority of stars take hundreds of millions of years to complete one orbit around the galactic center. The pace, however, gets astounding as you get closer. In a matter of years, some stars, referred to as SSRs, complete a circle around the black hole at speeds of thousands of kilometers per second. By observing them, scientists have directly demonstrated the black hole's enormous pore, an unseen force that is only made evident by the frenetic dancing of neighboring stars. These stars seem like dim pinpricks of light from Earth, but we can learn a lot from their movement. They serve as a reminder that there is an invisible gravity and a frenzied speed even in the still night above. Their dazzling orbits provide a window into the unadulterated might at the core of our galaxy. Like slingshot stones, hypervelocity stars are propelled outward. Occasionally, a star is captured in a fatal collision with the galaxy's central black hole. Tidal forces have the power to split a binary pair if it gets too near, ensnaring one star and sending the other hurtling outward at breakneck speed. Known as hypervelocity stars, these exiles travel through the Milky Way at speeds of millions of kilometers per hour, which will eventually allow them to completely escape. Their incredible velocities are revealed by rigorous measurements, although they appear to be identical to regular stars to the unaided eye. They are cosmic runaways, ripped from their homes by the cruel grip of gravity. All of them have a past filled with upheaval and near-death experiences. it is sobering to consider stars themselves straying into intergalactic space. Whole suns float away into the unending darkness, never to return to the galaxy from whence they were born. Without their own suns, rogue planets move stealthily through the night sky. While most planets are attached to stars, not all of them stay that way. Some are sent drifting through the galaxy after being evicted from their systems. Without a sun to keep them warm, these are lonesome worlds known as rogue planets. They can number in the billions, possibly surpassing the number of stars, although they are invisible to the naked eye. Some may contain radioactive decay, dense atmospheres, subterranean oceans, or heat retained by internal energy. If life were possible at such locations, it would flourish in the never-ending darkness, shielded from the stars for all time. By observing the slight bending of background starlight as a rogue world passes in front of them, astronomers are able to identify them through minor gravitational effects. The question of how many of these exiles might float between the stars undetected is made more complex with each new finding. They serve as a reminder that not every planet is a part of well-known systems. Many roam the vast emptiness by themselves, silent and icy. Entire regions are hidden from view by massive clouds of dust. Large swaths of space are obscured, yet the sky seems clean and transparent. Fine granules of interstellar dust, which are smaller than smoke particles, float in massive clouds that obstruct light. Rich areas of the Milky Way can become dark patches as a result of these clouds, which can block out entire star clusters. They appeared to ancient observers as voids in the sky, devoid of stars. However, scientists now understand that they are nurseries, where collapsing gas gives birth to stars. Gravity brings materials together inside them, igniting new suns. Dust shields delicate beginnings from harsh radiation, but it also obscures their beauty. These clouds are contradictory. They both generate and conceal, concealing stars as they emerge. Astronomers examine the inside using radio and infrared light to see structures that are invisible to the naked eye. It turns out that birth and becoming abound in the darkness between the stars. These clouds are penetrated by infrared light, which reveals hidden suns. Longer wavelengths of light pass through dust, but visible light is blocked. The stars and structures concealed within dark nebulae are revealed by infrared radiation, which is invisible to the naked eye. Newborn suns blazing in their dust cocoons can be seen by telescopes set to these wavelengths. Additionally, they reveal planetary disks, which are the early stages of solar systems developing around young stars. Our perspective has changed as a result of missions like the James Webb Space Telescope and the Spitzer Space Telescope, which have revealed hidden brightness in otherwise dark environments. Where the unaided sight perceives nothing but darkness, infrared displays solar clusters, gas filaments, and galaxies obscured by their own dust. It's like pulling back the curtain on the cosmos to see what's underneath. Even though the universe appears to be dark, it is not. It is full of hidden beauty that is just waiting to be seen with the correct kind of vision. It takes billions of years for quasar radio waves to reach us. Quasars, rather than nearby stars, are the source of some of the universe's strongest signals. Incredibly huge black holes at the core of dazzling dynamic galaxies. Extreme heat is produced as matter spirals toward these black holes, ejecting radiation in all directions, particularly radio waves. These signals travel for billions of years before they reach Earth, covering unthinkable distances. Because they are so far away, many quasars shine from a time when the cosmos was much younger than it is now. They are old-fashioned lighthouses. Time and space are cut through by their constant releases. Earthly radio telescopes pick up their faint murmurs and convert them into information that shows how galaxies and black holes are expanding. Listening to a quasar is like hearing voices from the very beginnings of creation, echoes of a universe yet in its adolescence. There are quasars that shine brighter than entire galaxies put together. Despite being driven by black holes, quasars are not at all gloomy. One quasar can outshine all the stars in its host galaxy due to the strength of its fire. Matter swirling downward, heated to millions of degrees as it descends, is what gives them their brilliance. Particle jets that span millions of light-years are released by some. Across the universe, enormous rays can be seen. Although a quasar seems to be a dim star to the naked eye, it contains energy that is higher than that of entire galaxies. Creation and annihilation are intertwined in these cosmic riddles. Quasars light up the far-off cosmos, indicating the positions of galaxies from the early stages of the universe's formation. Through billions of years, their light finds its way to us as a testament to both beauty and violence. Realizing how strong the universe's engines are is made possible by the knowledge that such brightness resides so far away. For brief durations, gamma-ray bursts shine brighter than the entire universe. Gamma-ray bursts, which are brief explosions that release more energy in a matter of seconds than our sun will in a lifetime, are among the most violent known occurrences. They are believed to happen when neutron stars collide and produce shock waves through space, or when enormous stars collapse into black holes. Their light temporarily outweighs the total output of all the stars in the visible cosmos. Before fading into afterglows that may be detected in radio waves and X-rays, the majority barely last seconds, and some only milliseconds. Their light frequently started traveling billions of years ago because they are so far away. Even now, though, they continue to clean our instruments. Despite being invisible to the human eye, specialized satellites detect gamma-ray bursts and notify scientists of their brief existence. Even indirectly witnessing such strength is like facing the cosmic extremes. Explosions that disappear into silence after momentarily overshadowing creation itself. Signals from all around the spectrum are alive in the night sky. We only see a small portion of the cosmos, visible light, when we look up. Nevertheless, the entire electromagnetic spectrum is filled with messages from the cosmos. Faraway quasars emit radio waves. The universe's creation is echoed by microwaves. Dust clouds radiate infrared warmth. Hot young stars emit ultraviolet beams. Black hair blazes with X-rays. Cataclysms produce flashes of gamma rays and holes. Different layers of the same story are revealed by each band. In actuality, the silent sky is a symphony of light at various frequencies, humming with information. To get a more complete view of the cosmos, astronomers construct instruments that are tuned to these wavelengths. One note of a vast cosmic chord is glimpsed when one sees only invisible light. There is no stillness or silence in the night above. It has a secret vitality that makes it alive. The history of everything is carried by signals that are continuously woven into the darkness. Every skyward glance is a window into the universe's past. You see more than just space when you look up at the stars. Time is passing. Every glimmer of light is a historical messenger. Years, centuries, or billions of years may have passed throughout its trip. The older the narrative it bears, the farther away. Years ago, the closest stars showed us. We saw what the Andromeda galaxy looked like years ago. The universe as it existed just after the Big Bang is revealed by the weakest galaxies that we can identify. The light in the sky is piled like book pages, creating a huge archive. Every upward glance is into recollection rather than the present, the universe revealing to us its former state. Lying beneath the stars is like lying beneath history itself, engrossed in a light-written record that stretches back to the dawn of time. This concludes our voyage through the wonders of heaven, dear listener. From the silent illumination of planets to the swift movement of shadows over Earth during eclipses, from the gentle curtains of aurora that ripple in the polar skies to comets that pass by only once in a lifetime. Together, we have traversed a tapestry of time and light. We have felt the quiet of galaxies extending into the night, seen the radiance of distant stars, and followed the faint echoes of creation that continue to reverberate in the heavens. The sky serves as a reminder that life is big, old, and full of surprises. It demonstrates to us the vastness of the universe, as well as the tenuous ties of light that bind us to it. All the stars above are messengers from the past. Every planet serves as a reminder of what is possible. Every glimmer and shadow tells a new tale. Allow your breathing to settle into a comfortable rhythm as you lie here. Picture yourself under that endless canopy. Imagine the stillness of a clear night, the cool air surrounding you, and the countless constellations slowly rotating above you. Observe the Milky Way's sweep as it arches across the night. Faraway galaxies blazing like forgotten lanterns, comets trailing silver fire, all of it streaming into memory, into dreams, into silence. Innumerable generations have been born by the skies before us, and innumerable generations will follow. Its tale is not yet complete, and by looking up, neither is ours. Every conscious thought softly fades into sleep, just as day gives way to night. As soon as you're ready, you can watch the following video if you're still awake. However, if your eyes are getting sleepy, allow the silence of the heavens to gently lull you to sleep. Shut your eyes, take a deep breath, and let yourself fall asleep, into silence, into the eternal and immense silence where the stars themselves watch. Good night.